Finally, the lesson you've all been waiting for. Rational equation word problems. The greatest topic of all time. So rational equations are used often in problems related to rate and time, or what we call work problems. These problems typically involve two or more machines completing a certain task. We can use the following basic setup to solve these type of problems. So 1 over whatever the first thing is, the time for the first thing, plus 1 over the time for the second thing is going to be equal to 1 over the time for both of them together. Now, here's an example problem. Wolfgang can compose an entire symphony in 10 hours, whereas Ludwig takes 15 hours to compose an entire symphony. How long would it take for them to compose a whole symphony together under their new supergroup, Beatsart? That's our question. Let's find out. So, in this case, remember what we have to do is we have to do 1 over our first person. So in this case, our first thing that we have is that Wolfgang is composing an entire symphony in 10 hours. So I'm going to say 1 over 10 for how long it takes for Wolfgang. Then we have Ludwig, who takes 15 hours. So I'm going to say plus, let's rewrite that plus, make it look a little better, 1 over 15. That's going to equal 1 over whatever the speed is. So in this case, let's see. Greatest common denominator between 10 and 15 is 30. So it's like 1 over 30. So for this first part, I'd have to multiply it by 3. So that would be like 3 plus 2 over 30. That's going to equal still 1 over x, meaning 5 over 30 is 1 over x. So if I cross multiply, I get 5x equals 30. And when I divide by 5, x equals 6. 6 hours. Rock! All right, let's look at problem 2. 2 inlet pipes are both open. They can fill a pool in an hour 12 minutes. Now, if one of them is closed, one of the pipes can fill it by itself in 2 hours. So how long would it take the other pipe? So let's start with the pipes individually. We have 1 over 2 hours plus 1 over who knows how many hours. And that's going to be the same as 1 over, we have minutes. So at this point we have a choice. We could make this 1 over 120 plus 1 over x equals 1 over something. Or I can say that 1 hour and 12 minutes is the same as 1.2 because it's 1/5 of an hour. Now, I will tell you, I do not like this fraction. This fraction needs to change. So my first whole number I get from this fraction is if I multiply it by 5, at which point I get 5 over, well, let's see, 12 times 5, that's going to be 6. So this is really 5/6. Now that we know that, let's talk about our other side. So our least common denominator between 2 and x is 2x. So that means this becomes x on top. The other side becomes 2. X over 2 plus 2x over 2x equals 5 over 6. Then I just cross multiply. 6x plus 12 equals 10x. At which point, subtract the 6. 12 equals 4x. X equals 3 hours. It should take 3 hours. Okay, let's try this one. You and your friend work together doing lawn work for your neighbors. Usually you work together and it takes an hour and a half to mow and trim one of your neighbor's lawns. But your friend has done work by himself before, and it only took him 2 hours to do it by himself. So the question is, how long would it take you to mow and trim the lawn by yourself? So let's go. 1 over 2 hours for your friend plus 1 over x hours for you is the same as 1 over, well, let's see. That would become 1.5 whenever I'm doing 1.5, which, by the way, turns into 2 over 3. So x plus 2 over 2x equals 2/3. So 3x plus 2 equals 4x. Not plus 2, plus 6 equals 4x. That means 6 equals x. That's right. It takes you 6 hours to do it by yourself. That means you are bad at this. You are taking too long. Do not take as many breaks. Come on. All right. Another type of problem that uses rational expressions are distance, rate, and time problems. For those type of problems, it can help to use a table to hold all our information. Just remember that distance always equals rate times time, which also means the distance over rate is equal to time. Let's look at an example problem. To travel 60 miles, it takes Sue riding a moped 2 hours less time than it takes Doreen to travel 50 miles riding a bicycle. Sue travels 10 miles per hour faster than Doreen, so find the rates and times for both girls. Now, some people have problems with why does it take longer for things or all of that, and here's the reason why. So let's look. Sue is traveling 60 miles, whereas Doreen is going to travel 50. Now, in this case, I know that Sue travels 10 miles per hour faster than Doreen. So if I say that Doreen is x, Sue is going to be x plus 10. Then, if I'm talking about time, remember, distance over rate is time. So 60 over x plus 10 and 50 over x. Now I know some of you are thinking, let's say that these two are equal. But the problem is they are not equal yet. And why are they not equal? Because it takes Sue 2 hours less. So if I'm saying that this is Sue's time, and Doreen, let's say, went for 5 hours or for 10 hours. If Doreen went for 10 hours, we know that Sue takes 2 hours less. So I would take Doreen's 10 and subtract 2. Now these work. So let's see. That's 60 over x plus 10. And that's going to equal negative 2x plus 50 over x. At which point I cross multiply 60x. Oh, by the way, the reason why it's that, in case you weren't quite sure, is because I had to get a common denominator of x. So this became negative 2x at that point. So this becomes 60x, and that's going to equal, let's see. Well, negative 2x plus 50 times x plus 10. So that becomes negative 2x squared. And then negative 20 plus 50, that becomes plus 30x. And then plus 500. So I want to combine everything. That means negative 2x squared minus 30x plus 500 equals 0. But I don't like that negative 2. And since these are all multiples of 2, I'm going to say 0 is x squared minus plus 15x, and then minus 250 if I'm dividing by negative 2. At which point I need two numbers that multiply to be 250 and have a difference of 15. Let's see. Oh wait, 25 and 10. Those work. So it becomes x plus 25 times x minus 10 equals 0, meaning x is either going to be 10 or negative 25. So how do I choose between those numbers? Well, remember, I'm talking about speed. And since I'm talking about speed, that means I have to choose the positive, meaning 10 miles an hour and 20 miles an hour. Then when I plug that in, let's see, 60 over 10 plus 10, so 60 over 20, that means 3 hours for Sue, and 50 over 10, 5 hours for Doreen. Julian's boat will go 15 miles an hour in still water. If he can go 12 miles downstream in the same amount of time it takes for him to go 9 miles upstream, what's his current speed? So remember, basically, we know that his generic speed is 15. That's his normal rate. But in this case, he went 12 miles downstream and 9 miles upstream, meaning whatever the rate of the current is, upstream, it's taking away the current, and downstream, we're adding the current, meaning 9 over 15 minus x and is equal to 12 over 15 plus x, at which point, by the way, the reason why I know that they're the same is it says the same amount of time right here. So, going to cross multiply, 135 plus 9x equals 180 minus 12x. So when I combine, that becomes 21x equals 45. X is equal to 7 1/7. Sorry, not 7 1/7. Whoa. It's 15/7 or 2 1/7. That's a much better answer. All right. Ooh, Accio bonus question. With her firebolt, Helena can fly 525 miles in 30 minutes, less time than it takes Benedict to travel 280 miles on his clean sweep. The firebolt travels about 10 miles an hour faster than twice the clean sweep. So we're going to find the speed of both brooms. So let's see. Distance for Helena, 525 miles. For Benedict, 280. Now, I know about rate that if Benedict's speed is x, then Helena's is x plus 10. Oh, wait, except it's 2 times x plus 10. Let's rewrite that. 2, that's 10 miles an hour faster than 2 times the clean sweep, which is not a very fast broom. All right, so if I wrote that, I would say 525 over 2x plus 10. And I would say Benedict was 280 over x. But there's a problem. We have to deal with the fact that it's 30 minutes less for Helena. So if I'm saying that this is Helena's time, then I have to take into account that Benedict's is going to be 30 minutes longer. So, in other words, if it took Benedict 3 hours, it's only taking Helena 2.5 hours. So I have to subtract half an hour. Since we're talking about hours, I'm going to write that as 1 over 2. So, first thing I have to notice here, I can just write one side. 525 over 2x plus 10. But on the other side, I'm going to have to figure this out and figure out a common denominator. That's going to be 2x. So I actually already know it's over 2x. But that means it's negative x and then plus 560. So now let's deal with the problem. We're going to cross multiply. That means 1050x, that's 525 times 2x, is going to equal, we're going to have to FOIL a little, negative x plus 560 times 2x plus 10. So let's see. Negative 2x squared minus 10x plus 1120x and then plus 5,600. So we end up getting negative 2x squared plus 1,110x, because we have to combine our two x's, plus 5,600. At this point, I subtract my 1,050, and I end up getting negative 2x squared plus, in this case, our leftover is 60x, and then plus 5,600. And that's going to equal 0, at which point I divide everything by -2. 0 equals x squared minus 30x minus 2,800. At which point I need to figure out what two numbers multiply to be 2,800. So I'm going to start with my multiples of 7 and 4. So like 7 and 400. Nope. 70 and 40. That one works, at which point 70 is the negative, 40 is the positive. X minus 70 times x plus 40. Meaning x is going to either equal 70 or negative 40, which means x is going to equal 70, meaning that is the speed of our clean sweep, and the speed of the firebolt, let's see, 2 times 70 is 140, plus 10 is 150 miles per hour. All right, inverse proportionality. When we say two values are inversely proportional, we mean that as one goes up, the other goes down. For example, as the number of people doing a job like painting goes up, the time it takes to complete a job goes down. In math, it looks like this. P equals K over T, where P is the number of people, T is the number of hours. We also sometimes see this, by the way, where we're talking about like a cash prize. But before we do that, we have to know what K means, and K is the constant. We have to determine that value. Now, sometimes we know the value. For instance, if I say that there is a competition going on, a musical competition, and the winner gets $100. If you enter it as a solo artist and you win, you get the full $100. But if you're a band of 5 people, that means when you win, you only get $20 each. That's the idea. So we have to determine the K value, though, most of the time. Let's look at an example. So it takes 4 hours for 3 people to set up a backdrop. So the first thing we have to do is find our K value. And to do that, we plug it in. So let's see. P is number of people, so that's 3. And that's going to be K over the 4 hours it takes. So to get K by itself, we would multiply both sides by 4. Sorry, I don't cancel out that 4. I cancel out the other side. 4 times 3 is 12. So now that I know K is 12, how many people would it take to complete the job in 2 hours? So I'm now looking for people, but I have K, and that's going to be divided by 2. Sorry, I know K. That was the whole point. K is 12 divided by 2, meaning you would need 6 people to complete the job in 2 hours. How much time would it take 8 people to complete? So in that case, it's 8 equals 12 over T. Now, in this case, remember, it should work the other way as well, but we want to get T on top. So 8T equals 12, meaning T equals 12 over 8, which is 3 over 2, or 1.5 hours. And that's word problems. That's about it for this unit. That's it for the lesson. It is it for this unit. If you want to see other ones, I've put this on a playlist, which I think I'm probably linking to right now. I'm assuming, probably up here. Also, please subscribe. Thank you. Have a good day.